Hey math fans, it's test 4 lesson 2. If your swords are ready, let's go. Today we're going to talk about how to express theoretical probabilities of fraction and how to solve problems with fractions. So we'll begin by checking in on expressing theoretical probability as a fraction. So before we go too far into how to express theoretical probability, we should talk about what it is. So the important thing to know is that there are two types of probability. There's experimental probability, and there is theoretical probability. So experimental probability means you actually did an experiment. It's a fraction or ratio that compares the number of times an outcome occurs in an experiment with the number of times the experiment is done. So the example is, I flipped a coin 10 times, I got heads 6 times and tails 4 times, so that means the experimental probability of getting heads was 6 flips out of 10, or 6/10. Theoretical probability is a fraction or ratio that compares the number of ways an event can happen with the number of equally likely outcomes. Theoretical probability is always between 0 and 1, which means it's always written as a decimal or a fraction. So this is the theoretical probability. If you flip a coin, you have an equal chance of getting heads or tails. If you flip it 10 times, half of those should be heads. The theoretical probability of getting heads when you toss 10 coins is 5 out of 10, or 5/10. So basically, the simplest thing to remember is theoretical probability is what should happen. Experimental probability is what does happen when you do the experiment. So if I toss a coin, I should have a 50-50 chance of getting heads or tails. Half the time I should get heads, half the time I should get tails. If I do an experiment, that might not be what happens. In my experiment, I did it 10 times, and 6 of the time I got heads, so that's 60%. It was close, but it's not quite right. If you do the experiment lots and lots of times, you'll get closer to the theoretical probability. So if I only flip the coin 1 time and I get heads, then that means 100% of the time I got heads, but it wasn't a very good experiment. If I do it 10 times, that might be a bit closer. If I do it 1,000 times, I'll probably get much closer to the theoretical probability. However, theoretical probability is what should happen. Experimental probability is what does happen. Theoretical probability is always between 0 and 1, which means we always write it as a fraction. If you toss the coin 10 times, you should get heads 5 times, 5 out of 10. And let's move on. We'll talk about solving problems with fractions. So when you're doing problems, you're going to find that there's a lot of problems that sound complicated, and really all they're asking you is how many fraction pieces are in one whole. So for example, how many thirds are in one whole? So there you see a flag, it's divided into thirds. How many thirds are in a whole? There are 3 thirds in one whole. How many quarters are in one whole? There's 4 quarters in one whole. How many halves are in one whole? There's 2 halves in a whole. So if I ask you how many fraction pieces are in one whole, you just have to remember that if I write a fraction, the bottom number is telling me how many pieces are in the whole. Simple enough. There's a lot of problems that sound complicated, and like I said, really this is all they're asking you. So we'll look at an example. So here we have a problem. Joey puts up a sign advertising his garage sale every 1/8 of a kilometer for 3 kilometers. How many signs does he need? All this is really asking me to figure out is how many eighths are in each kilometer. So if it's an eighth, that means there's 8 eighths in one whole kilometer. 8 eighths equals 1 kilometer or kilometer. That means if he put a sign every 1/8 of a kilometer, that means that for every 1 kilometer he put up 8 signs. So how many signs does he need? Well, 1 kilometer gets 8 signs, so 3 kilometers is going to get 3 times 8, 24 signs. And there's my answer. He needs 24 signs. So really, we're not looking at anything that's all that complicated. We are just looking at explaining how many pieces are in each whole. And that brings us to your review for today. So question number 1, if you toss a coin 20 times, what is the theoretical probability of getting heads? Write your answer as a fraction. And number 2, Macy is planning a race. She sets up a checkpoint every quarter kilometer for 5 kilometers. How many checkpoints does she need? So answer those 2 questions, please, and bring them to school tomorrow, and I will see you then. Have a great night.